Hi, and welcome to episode 2 of Theory in 3 Minutes. Now, in this episode, we are going to be looking at data structures. The English language is made up of alphabets. If we want to form a word, we put a group of alphabets together and we form a word. If we want to form a sentence, we put two or more words together and we form a sentence. If we add two or more sentences together, we form a paragraph. Now, programming languages are also made up of primitive data types. Examples of primitive data types are integers, are strings, are booleans. Now, if we put a group of primitive data types together, we get a data structure. So, a data structure is a group of primitive data types treated as a single unit. Now, data structures are classified into two main categories. The first is linear data structures, and the second is nonlinear data structures. Now, in linear data structures, we have arrays, we have stack, which is literally stacking things on top of each other. We have the queue, which operates in the first in, first out principle, and then we have the linked list. Now, with nonlinear data structures, we have trees and we have graphs. A few things to note about data structures. A data structure can be assigned to a variable. A data structure can be used as the input parameter for a function, and a data structure can be returned as the result from a function. Let's say we want to write a grading application where a user enters a list of students and we return to the user a list of students sorted in descending order based on the marks of the students. Now, we remember from our lesson from algorithms that we have the input, we have the process, and we have the output. So the input for our program is a list of students. So we have to ask ourselves that in the programming language we are writing, how do we implement a list? If we are writing in JavaScript, we can use an array. If we are writing in Python or in C#, we can use a list. Now, this program has a list of students where each student has a name and a mark. These are two primitive data types we are adding together, which means we need to create another data structure, which is an object. So our list of students is going to be a list of objects. We are going to process that list. We are going to sort it in descending order. And we are going to return a result, which is also another list to the user. Let's look at the code and see how we are going to implement this. I have already implemented the core of the application, and we are just going to add the data structures. So the first is to create a list of students. Now in JavaScript, a list is represented by an array. So we'll create an array called students represented by curly braces. Now this application accepts the name and the marks of the students. So let's create an object, say new students, where we have the name and the marks of the students. Now, when we get the name and the mark, we add this to the array of students. Let's try this out. One, and enter a mark. Two, enter a mark. And three, and enter another mark. And we see that the application returns to us a sorted list in descending order based on the marks of the students. So the next time you're building your application, remember step 1 is your algorithm, and step 2 is your data structures. What are the data structures I need to implement the algorithm efficiently? Now, in the next episode, we are going to look at the big O notation, which is how to measure the efficiency of your algorithms. If you like this video, click the like button and click the subscribe button so that more people can see the channel. See you in the next episode.